Today we're going to finish up section 2.1, Reasoning and Logic. We had looked at a variety of things so far in this section, and we had just introduced De Morgan's laws when we left. So De Morgan's laws looked like this, and I told you that my unfortunate computer did not put the third line in there because I don't have that symbol in the computer, but that's okay, we did, and we're all good, right? So just a reminder of the way De Morgan's laws work sort of notationally. When we have that tilde, which means negation, on the outside of a grouping symbol like parentheses, it distributes through the parentheses by affecting all three pieces inside. It affects both of the statements. So in this case, if there are statements that are already set in a positive sense, P or Q, it's going to make them not P and not Q. And then it changes ands to ors or ors to ands. Okay? So what we're going to do then is we're going to do some examples with some language on how that works. Did we do these two yet? No. Okay. Then, you know what? Let me just do what I just said we were going to do, and we'll come back to 3 and 4 in just a second, because I think it's more interesting to see how this works maybe than the symbols. All right, so here's an example of a statement. This is example number 5. Sorry, and I'm not going to go in order apparently in your notes today because I don't feel like it. I don't know. I don't even see example 5. Do you have example 5 written there? Oh, I do. I should change that, shouldn't I? I'm definitely missing out today. Okay, example 5. So our statement, our compound statement says, it is not sunny and I will go for a walk. So there are 3 pieces of information that all have to be changed. The first statement says it is not sunny. The second statement says I will go for a walk. And what's combining them, we call it a connective, is the word and. So all 3 of those pieces are going to change when we write the negation for this. So what would be the negation of it is not sunny?
It is sunny.
Right. It is sunny. When we do a negation with the word and, what will it become? Or. And what would the negation of I will go for a walk be? I will not go for a walk. Okay, so do you kind of have the sense of how the negation works? Now let's think about the 2 statements actually and why they make sense. This says it is not sunny, so you might imagine in your mind a cloudy day where you're going out to walk, correct? And the exact opposite of that statement is a statement where one of those 2 pieces fails to be true. Namely, it's a day that is sunny or it's a day that you're not going for a walk. And that's exactly what we wrote down, right? It is sunny. Yeah, that's what I said. And then we have the not walk happening, basically. We're lazy. Maybe we went for a run. We can say it that way. That's what we did instead. We are overachievers for that day. Okay, let's go back then and work a little bit with truth tables and how to do negations with symbols of these, okay? So it says to use De Morgan's laws to write a negation of P and tilde Q. So this is just the symbols part. If we're negating P, what does it look like? Tilde P. The symbol that looks like the upside down V, if we're negating that, what will it become? A V. And if we're negating tilde Q, what will it become?
Just Q.
Just Q. Exactly. So symbols-wise, it's just 3 pieces that change. Language-wise, it's introducing this negation concept how we did last time. And then what we're going to do is we're going to prove or verify that both the statement tilde P and tilde Q, this one right here with the negation on the outside, and this statement that we created right here in number 3 are logically equivalent. Now, we encountered the phrase logically equivalent last time, but we didn't do anything with it. So just as a reminder of what it means, logically equivalent means 2 statements that have the same truth value in every possible situation. Okay? Same possible truth value. What that really boils down to, and I would encourage you to jot a note down that says this, is the final column of their truth tables match. That's what it means to have the same truth value in every possible situation. So, if we're taking a look at these 2 statements, we compare them by making a truth table for each one. Okay? So we're going to have 2 truth tables. one of our truth tables, they both will start out P, Q. Okay, that part will be the same in our two truth tables. Let's do this one first, okay? What else do I need in my truth table for the one that I circled in yellow besides P and Q? Tilde P. Very good. I'm going to need a tilde P. And I'll draw my next column line. What else am I going to need? I need the trues and falses, but let's just do column headers for just a second. What is I need another column header. The full thing, exactly. Because I've got all of the individual pieces now, I just need to combine them together. Okay? So, we're going to do what Shelby said next. We're going to fill this in with the T's and the F's. Okay? Because we've got all the column headers. It finally ends with the culmination of everything. You know, the entire statement. All right, so what will the P column always say? True, true, false, false. What will the Q column always say? True, false, true, false. All right, so now we're actually ready to do something that's not the same on everything. So we've got a tilde P column in this particular one. What will the tilde P column look like? The exact opposite or the reverse of P, right? So P says true, true, false, false. So tilde P is going to say false, false, true, true. All right. So then, our final column of our truth table is going to reflect back to the individual pieces that are in that final column's header. Tilde P, which is this one, and Q, which is this one. So those are the two columns we're comparing, that we're using as we make our decisions. And this statement is a what kind of statement? It's an or statement, right? Symbol right there between them is or. So when is a truth statement that's an or? When is an or statement true? When either one is true. Can both also be true, Shelby? Do you remember?
No, oh wait, no, yes,
they can. If they're both true, it's still okay. Yeah, so if either one of them or both of them are true, then an or statement's true. So along my first row, it says true, false. So that would be true. The second column, or second row, excuse me, says false, false. That's false. The third row says true, true. That's true. And the fourth row says false, true. And that's true. Okie dokie. You ready for the other one that we're comparing this to? Okay, the one that we're supposed to be comparing this to is this one right here. We should end up with a final column of our truth table that matches the one we just got, if we've done it correctly, and they really are negations. The first two columns stay the same, P, Q. And then, just like with algebra, you're working inside of parentheses to the outside, right? Think like order of operations. You start inside. So looking on the inside of the parentheses of the one that's in sort of circled in orange, what else is inside the parentheses that I need to deal with? I have a tilde, right? I've got this piece right here, tilde Q. So I need a tilde Q column. What else do I need? The full length of this, we call it a statement, the full length of the statement that's in the parentheses, okay? So that would be the P and tilde Q in this case. And then what do I need? The whole point is that we're trying to show that this actually is true. Basically what we're doing is we're trying to show that this side equals this side. That's our goal. So if I foiled it like what you're suggesting, it would just turn into this, which is kind of missing the point. Are you with me?
Yeah.
Like our point is to really show that they're the same without doing any symbolic manipulation. Okay? So what am I missing then in my truth table? Okay, I'm glad you actually said that, Hannah. I don't need a tilde P because there's not a tilde P in this particular grouping. What else did you have in mind, Shelby? We already have an and, there's not an or in this grouping. The tilde that's on the outside, however, doesn't have a place yet, correct? Okay, I need an expression that shows the tilde on the outside affecting the P and tilde Q. In other words, I need the final column that reflects all of this put together. Okay, you all know how to do your P column and your Q column, so fill those in. What will my Q column say? My tilde Q column say? False, true, exactly. Just reverse of the Q column. All right, the next column actually needs me to compare or combine two of these columns, the P column and the tilde Q column. So these are the two columns I'm going to look at, and I'm going to be comparing them under the operation AND. When is an AND statement true? When they're both true, right? This was the professor and woman examples that I was given last time, when they're both true. So on my first row, I have true, false, which would be false. Second row, I have true, true, which would be true. Third row, I have false, false, which would be false. And then the fourth row, I have false, true, which would be false. Good job. Last column. The last column is a negation of the column before it, correct? All it is a tilde outside of what I already did. So how do I do that?
Do the opposite of that.
Yeah, I'll just take the column I just created and I will do the opposite. So false becomes true, true becomes false, false becomes true, false becomes true. And what you should notice at the end is that those final two columns of each individual truth table match. What that's showing, or verifying is the word that they use, but verifying is that De Morgan's laws actually hold true. That if I distribute, like the word you'd mentioned with foiling or whatever, if I distribute through the negation, it's actually creating exactly the same statement as if the negation were on the outside. Okay? Alrighty. This is where I want to do it. Okay. There's, well, we'll do this. I don't know why, but I just want to go out of order today. I'm just like wanting to buck the system. And I created the system. Like I put it in here. Right? So like that's kind of crazy. All right. We'll go with this piece, and then I've got space at the bottom of your paper. I want to show you one more thing. Conditionals. Conditionals are statements that are expressed in the form if P, then Q. They're also read P implies Q. And notationally, the way that they are written is with an arrow. P, arrow, Q. The hypothesis is the if part of the conditional. P, the way that I've written it. And the then part of the conditional is the conclusion. Q, as I wrote it. If it rains today, then I will sleep in. Right? If I get a bad grade, then I will study. Don't do that. That's a bad plan. Okay? We say if-thens all the time. If this, then that. Okay? So you guys are very familiar with this type of part of speech, or a type of speech. If-thens. What I wanted to show you is how to do a truth table for an if-then. Okay, so I want you to create a truth table with 3 columns, P, Q, and P, arrow, Q. And your P and your Q columns, of course, are the same way that they were before. True, true, false, false, true, false, true, false. Of all three, the truth tables that we've really done, I don't really count negation as an example, but if you want to, we've done 4 truth tables then. This one's the hardest to reason through, okay? So the examples that we're going to use are this. P is I am a mom. Is that right? Or is that backwards? How I normally do it. Hang on, let me think just a second. Don't write that down. Yeah, that's how I know to do it. I should really write this in my notes. Okay, I am a woman is Q. Okay, I'm a mom, I am a woman. These are the two. Okay, so you are talking with someone on the phone, so you absolutely have no idea if they're a man or a woman. You don't know them. You don't know if they're a mom or they're a dad. They're an aunt. You don't know anything about them, okay? Their name is gender neutral. That's the deal, okay? So you've got this person on the phone, and they say, if I'm a mom, then I am a woman. And you say, true. Right? That has to be the truth of the statement. That's what we mean by that language. If I'm a mom, then I'm a woman. True. So 2 true statements result in a true statement for a conditional. Okay? Those are kind of nice because that's actually true for all of our connectives, right? Ands, ors, if-thens. 2 truths give me a true statement. The next one. The person says, if I am a mom, then I am not a woman. And you say, false. That doesn't even make any sense, right? That is a false statement. What you just said is illogical. Okay, so are we good so far? The next time, next person you're on the phone with, all the same situations we had before, they say, if I am not a mom, then I'm a woman. It could be true, right? So you have to presume, it's almost like they're telling you, I'm not a mom, but I'm a woman, and you're like, well, okay, yeah, that could be true. Right? So we're giving them the benefit of the doubt that they're being honest with us. Okay? So you're saying, okay, that could be a true statement. And then the last situation is that they say, I am not a mom, or if I am not a mom, then I am not a woman. And that also could be true, right? Somebody who's a man on the phone, right? Something like that. Okay, so that also could be true. So this is really an awkward way of describing this because this doesn't sort of fit the same description, like visually, that the other ones did. The 2 truths, we're all good to go on that one. That was true for all of our statements, right? Ands, ors, and if-thens. But a conditional will also be true if it starts out false. In particular, anytime you have an if-then statement that starts out false, it's a true statement at the end. It's a little weird, but that is the way it works. It's the benefit of the doubt that somebody's telling you the truth. That's the idea. Okay, so we're going to do a little bit more with conditionals. We're going to do a couple of statements you may or may not be familiar with. Let P be the statement you build it, and Q be the statement they will come. Do you guys know where that's from? Is this going to be the semester that I finally got a group of students and nobody knows where that comes from? Does anybody know? Huh? Nope, not Bob the Builder. It is a movie. It is television. The statements, you build it and they will come.
Oh, that's from Field of Dreams.
That's the one, Field of Dreams. Yeah, Field of Dreams. So, he's building a baseball field and a cornfield, if you're familiar with him. It's a good movie. I actually would encourage you to watch it if you haven't. But, all right, we're going to use some symbols. All right, so the directions on this have those statements. P is the statement, you build it, and Q is the statement, they will come. And we're going to write the following in symbolic form. Now there's a catch with conditionals. The catch is this. Wherever the if is, the hypothesis comes right after the if. So the if doesn't have to be at the beginning. That's usually how we say it. But sometimes we put the if in the middle of something, right? We say something like, I am going to eat dessert if I work out today. But the if part is the working out, right? That's what's going on here too. So the if you build it is actually the hypothesis here. And what its symbol is being used for that? P or Q? P. P was the statement you build it, right? At the beginning. So the P starts it out, and then the arrow comes after the P. And we go sort of back to the beginning of the sentence. They will come, and they will come is the symbol Q that we were given, right? If you build it, they will come. They will come if you build it. It's the same statement. The same compound statement even. On the second one, it's a little bit easier because the if actually shows up at the beginning. It says if you do not build it. So what is that going to look like? Tilde P. P is you will build it, so tilde P is you do not build it. And because it's an if-then statement, we do our arrow next, and it says, then they will not come. That is tilde Q. Okay, our next example is going to go in the reverse order. We're going to start with symbols, and we're going to write the statement that corresponds. So these statements, a little bit different. P is the statement, God loves me. And Q is the statement, I am a sinner. Okay? So what is going on with the first one? What symbol joins P and Q here? It's and. P is written first, so we will write P down first. And P is the statement, God loves me. What will I write down after I write down God loves me? And. Good. And then we'll write the statement Q, and Q is the statement, I am a sinner. This is a statement we believe to be true, right? It's one of the basic precepts of Christianity. All right, let's take a look at the second one. The second one is an if-then statement, right? How do I know? It has the arrow. So the statement's actually going to start out with the word if. And then I've got tilde P. Right. It would be if God does not love me. Okay, and then we'll have a then, and we will have the statement Q, because that's where we end on this. Then, I am a sinner. And in some sense, this statement doesn't even make any sense to us, because the first part, if God does not love me, is false. Right? It's a false statement to begin with. Cool. Good job, guys. All right. You're going to actually explore a little bit more with if-then statements in your work as they relate to this right here. Okay? A statement, a conditional statement, we've just discovered and explored is this P arrow Q business. Right? If P, then Q. And what I'd like to show you is what the converse, the inverse, and the contrapositive are as they relate to a statement P, or if P, then Q. A converse of the statement if P, then Q is if Q, then P. So you simply switch the location of where P and Q are located. And I'm not going to tell you the end result here, but the question you're going to explore is this statement logically equivalent to the first one? An inverse doesn't switch the order around, but it negates each individual piece. So you have not P implies not Q. And again, you're going to explore whether that is logically equivalent to one or both of the other statements that have already been made, the statement or the converse. And then the contrapositive is going to do both. It's going to switch the order and it's going to negate both pieces. So it's not Q implies not P. If not Q, then not P. All right, so we're going to pause for just a second so that I can show you the surprise that I told you we had for today. Are you ready? All right, so conditionals have these converse, inverse, and contrapositives that change the order of the statements or change the statements to their negations. And so what we're going to do is we're going to talk about if I'm a monkey, I have a tail. And we're going to create the converse, the inverse, and the contrapositive for that statement. So the statement already has a connective of if-then, right? The word then is not actually there. It doesn't have to be. It's understood to be. The two statements we have are I am a monkey and I have a tail. No apes in this particular statement, the way it's written. All right? But we're going to do the converse first. So to do the converse, what changes? What changes? The order changes. Okay, so the negation doesn't happen, but the order changes. So instead of having the monkey part first, what will be first? The tail part, right? And the statement will still start out with the if at the beginning. Okay, so don't go moving the if around. That will confuse and mess things up. Leave if and then where they are. If I have a tail, that would be changing the order. Then what? Then I am a monkey. Okay, that's the converse. Inverse is next. What do I do when I create an inverse? I negate the P and I negate the Q, but they stay where they were from the original statement. Okay, if is still at the beginning, but instead of it saying, if I am a monkey, what will it say? If I am not a monkey, then what? Then I do not have a tail. And then the last one is contrapositive. So what does a contrapositive do? Yeah, it reverses the statements and it makes them negations. So instead of having the monkey part at the beginning, I'm going to have the tail part at the beginning. But instead of it saying, if I have a tail, I'm going to say, if I do not. All right, so we're starting with an if. So if I do not have a tail, then what? Then I am not a monkey. Now take a look at these statements. Are these statements all equivalent to one another? One way to make that decision is to decide if they're true or not. If I'm a monkey, then I have a tail. Is that a true statement? Yeah, it is a true statement, especially even, I know it was a funny video, but according to the zookeeper he saw or whatever that Larry saw, that's a true statement, right? So is it a true statement that if I have a tail, then I'm a monkey?
No.
No. And can you give me a counter example?
Cow.
A cow, just like in the video, right? How about the second one, inverse? If I am not a monkey, then I do not have a tail. Is that true or is that false? That is false. Can you think of something that is not a monkey that does have a tail? The cow, right? Same example works. Which makes you start to wonder if maybe the converse and the inverse are the same statement, doesn't it? Because the cow worked to prove them both wrong. How about the last one, contrapositive? If I do not have a tail, then I am not a monkey.
True.
Also a true statement. We're trying to not, bring up like, well, what happens if somebody cut the tail off the monkey? That's not what we're talking about here. Okay, don't go cutting the tails off of monkeys. Okay. So at that point, the first statement was true and the last statement was true. So the question then becomes, are those equivalent? And I will let you decide as you work on your group work today.